information on analysis of temporal and spatial pattern of North American wildfire events using MODIS MAIAC data records.
Hi everyone, thank you so much for coming. I'm really happy to share my results. I'm Amanda Wang. I'm a rising high school senior from America. And so, last year the Canadian wildfires pretty heavily affected my area. And so under the mentorship of Dr. Alexei Lepustin, I was able to analyze the temporal and spatial patterns of wildfire activities across North America for the past 24 years. So, recent research has shown that there has been an increase in wildfire activities across the Western US for just in the past decade. And so these wildfire activities emit a large amount of aerosols into the atmosphere, which in turn inhibit air quality levels. And to address this issue, we analyzed the temporal and spatial patterns of these wildfire activities across North America using MAIAC AOD, or aerosol optical depth, and hotspot data. And we also analyzed a few confounding variables, such as column water vapor and near surface temperature, to see their correlation between these fire activities. So the first thing we did was we counted the number of high AOD pixels within each 1 by 1 degree box. And then we calculated the fraction of these high AOD pixels within each box. We defined a high AOD pixel as having a AOD value greater than 1, and then we finally aggregated the daily data into monthly data for easier analysis. We performed a similar procedure to account for the number of fire hotspot pixels in the area, as well as the number of column water vapor pixels. And then we extracted data from NOAA to calculate the near surface temperature anomalies, and that was also resampled into our 1 by 1 degree boxes for easier analysis. So our AOD hotspot and column water vapor data is all extracted from MAIAC data. MAIAC is a multidisciplinary atmospheric correction algorithm which uses spatial and temporal information to create more robust and accurate retrievals. So MAIAC data suite includes 1 kilometer resolution of things like AOD, water vapor, hotspot and cloud mask, surface reflectance, BRDF, and other daily values. And then we also use MERIT-2 data to account for the near surface temperatures. So the North American fire season typically ranges from May to September. And in this picture, it shows the spatial patterns of high AOD counts and hotspot counts. So, as I said before, these fire activities emit a large amount of aerosols into the atmosphere, and so they result in high AOD values in corresponding regions. So if we use that data and correspond it to the hotspot data in the same regions, we can actively identify where the extent to which a fire affects. So as you can see, the 2023 Canadian fires, we see a lot of high AOD pixels in the area, and then and then we also see the hotspot pixels in corresponding areas indicating an active wildfire. So this is June. This is June. As you can see, the same trends and more frequent fires are appearing as fire season continues. So July, same trends. We also noticed that in this month, there are more frequent fires in the most recent decade than in the past decade. August, same trends are existent. fires keep raging on as the fire season continues. Lastly, this is our time series analysis of every 10 by 20 degree boxes. So the first thing we notice is that so the first thing we notice is that in the 50 to 60 degree latitudes in Western and Central Canada, as well as the 40 to 50 degree latitudes of the Northwestern US, we see an increasing trend of high AOD values, number of high AOD pixels, as well as the number of hotspot pixels in corresponding regions. And so that indicates that there are more frequent fires in those regions. And then we also notice that in the 40 to 50 degree latitudes in the central and eastern US, that there is an increasing trend of high AOD pixels, however, very minimal hotspot pixels. And so that is most likely due to transported aerosols from nearby fires. And then moving down from the 30 to 40 degree latitudes in the central and eastern US, we see very few high AOD pixels, but a lot of hotspot pixels in the same region. And combined with the agricultural activity in that region, we are able to infer that these numbers are most likely due to controlled agricultural fires that do not emit as many aerosols as wildfires do. So further, we also analyzed the correlation between these fire activities and near surface temperatures. We saw a positive correlation between these fire activities and the positive surface temperature anomalies. So usually if there is a very strong fire, we will see a positive surface temperature anomaly. However, that does not mean there has to be a fire present if the surface temperature anomaly is positive. We saw this correlation between the months of May to July. However, it is not clear this finding still holds for the rest of fire season from August to September. We also analyzed the correlation between column water vapor and near surface temperature. We found that there is a correlation between the positive surface temperature anomalies and the positive column water vapor anomalies, and this is most likely due to the abundance of moisture in the soil during the spring and early summer being vaporized by the high temperatures. So overall, we demonstrated that earth sensing technology can be used to monitor these fire events across North America. Using that data, we were able to identify that there has been an increase in fire activities in the 50 to 60 degree latitudes in Western and Central Canada, as well as the 40 to 50 degree latitudes of the Northwestern US. Further, we identified that from May to July, there is a correlation between the positive surface temperature anomalies and fire activities. However, it is not clear that this finding still holds for the rest of fire season from August to September. We also found that in the same period from May to July, there is a correlation between the positive column water vapor anomalies and the positive surface temperature anomalies, and this is most likely due to the abundance of moisture in the soil and vegetation in the spring and early summer. Thank you everyone for your attention.